over the years, there's been a lot of very interesting and intricate query syntax ginned up to deal with row mode performance issues that that don't really exist anymore in a world where batch mode exists. One of them is called the carryover sort. I don't know if you've maybe ever run into a problem like this or whether you've ever stumbled upon this problem. I admit that the name is a little outlandish, but it comes up a lot when you're dealing with data analysis type work. And prior to there being batch mode, there was one specific way that you typically wanted to write queries if you wanted to sort of emulate what a windowing function would give you for like finding the max value for a row, not per column in a row, but just per row. That batch mode largely solves. So I'm going to talk about that today. Once we get over to SQL Server Management Studio, I'm going to show you probably why the query you think that you want to write is not right, just how slow the process of doing this using row mode is, and how batch mode improves that. But of course, we're going to contrast that with the carryover sort method, the way that it has been presented. This is not my syntax. Is I just it's something that I've run across, and I just wanted to make sure that I was comparing it accurately to modern versions of SQL Server. Of course, you may still need the carryover sort method of doing this if you are using standard edition of SQL Server. The reason for that is because if you are using standard edition of SQL Server, at least as of the recording of this video, Microsoft still does not think that you have paid them enough to be your friend, and they have deliberately hobbled anything involving batch mode and column store in standard edition to a DOP of 2, not even a DOP of 4, a DOP of 2. You can only use 2 cores when doing anything with column store or batch mode in standard edition, which is of course tremendously unfair as far as I'm concerned. 2 cores, that's it. 2. All right. Anyway, before we do that, what do you know? If you want to contribute to this channel, you can sign up for a membership. Link down in the video description for that. It's just a show of appreciation for all this cool content that I write and record for free. You can also like, comment, subscribe, and ask me questions for my office hours episodes. If you need SQL Server consulting help, boy howdy, I do all this stuff. And as always, my rates are reasonable. If you want to get all my performance tuning training, I have 24 hours of it for about $150 US. You can, and that lasts you for life. You get it forever and always. Just go to that URL, plug in that discount code, which is also a fully assembled link down yonder, and you can start your learning today. My new T-SQL course. The beginner content is all done and recorded. It's about 23 hours over 69 modules. If you are going to attend Kendra Little and I's T-SQL Pass Precons, you will get access to this material. And right now the course is on pre-sale for $250. It will go up to $500 when the course is fully recorded after the summer. I am hard at work on all the advanced material now, so isn't that spectacular for you, how hard I work? If you would like to see me live and in person, I am going on tour with the Redgate Roadshow, the Pass on tour dates. New York, August 18th and 19th, Dallas, September 15th and 16th, and Utrecht, not just an art supply store. It's a hamlet in the Netherlands, October 1st and 2nd. And then, of course, Past Data Community Summit in Seattle, November 17th to 21st. So with that out of the way, let's pratty, or party, whatever it is. So I have pre-run a couple things here. The first 2 things that I have pre-run are The version of this query that a lot of people will write, or maybe tried to write at some point in the far distant past, and were unhappy with the performance of, which is basically to select some stuff within a common table expression, and most importantly, in that common table expression, generate a row number. And the goal of the row number is for each post type ID, because that's what we're partitioning by, we want to order by the creation date converted to just a date. It's a date time. We're just converting it to a date. Then ordered by owner user ID descending, and then ordered by ID descending, with ID descending acting as a bit of a tiebreaker because ID is unique, and these other things are not guaranteed to be unique either individually or in concert. The second thing that I've run is a query that, and this is hinted to use optimizer compatibility level 140, because I do not want batch mode on rowstore to kick in and be enabled for this query. The second thing I've included with the first running of things is the query that a lot of people think could replace this. But this is not the right query to write for this, because what this is doing is it's getting you the max value for each column grouped by post type ID. That is not correct, because the real sort of algorithm, if you want to call it that, is that we are ordered first by creation date, then ordered by owner user ID, then ordered by ID. This is getting the max for each of those individually. The first thing that I want to show you is the results, because showing you the results shows you where these two methods no longer agree as far as the included data goes. So post type ID 1, the owner user ID, is different between these two. It's also different. It's also a different owner user ID for post type ID 2, and post type ID, well, 3, of course, right there. The IDs are different for these two as well. So really, the max method just does not give you the correct results. There's just too much different in here. Focusing over on the execution plan, we can ignore this one because this one does not give us the correct results. So let's just get that like way out of the way. We're not thinking about this one at all. This is the row mode version of the query, and you'll see if you follow along the operator times here, this thing runs for just about, well, a little over 14 seconds. I like to say 15 seconds. That feels good to me. So let's just say this thing ran for like 15 seconds, right? Nice fizz buzzy number there. And like really, you know, there's just not a whole lot to say about this generally. In row mode, queries like this are quite painful, even if you have a reasonable index for SQL Server to use to make the window function go faster. It's often just a terribly inefficient way of writing and running the query. So what I want to show you next is the carryover sort method. So what the carryover sort method aims to do is get the max. You see the max starts here and the max ends way down here. But what the max is doing is basically assembling a string based on getting the max of all three of the columns that we care about. The normal carryover sort thing does not include as much complexity for the second column as mine does. The problem that I was running into is that there are negative owner user IDs in the post table. And sure, I could have filtered them out, but that's cheating a little bit. We want to maintain all user IDs. We want to make sure that we even include the negative ones, because when the max is a negative number, then we need to consider that, don't we? We can't just not return a result for a row because we didn't feel like dealing with some potential abnormalities in the data. So I have a case expression here, and the case expression just says when owner user ID is less than 0, then I add some x's to the left, which is different from what we're doing when owner user ID is greater than 0 or greater than or equal to 0, because with that we are right padding the number. So we're like adding like zeros to the right of it. The reason that I did the X's is because if I zero padded it, things would have gotten messed up down in the select query. In the select query, we are basically asking for a substring and converting the substring to the correct data type. So when you do that with the ID column, and you have a zero padded number and you convert a right zero padded number to an integer, it's no problem, right? Because like you just remove the zeros from the front of it and you give the rest of the number. The problem with the negative number is that you essentially have a string, and if I added zeros in, then I wouldn't know if there were naturally occurring zeros in the number. So I used X's and I replaced the X's to avoid confusion there. But the carryover sort method just does this. We still group by post type ID. We're using the max function across, like we have 3 different columns in the max function, post type ID, creation date, owner user ID, and ID. And like we're assembling like the max across those 3, right? So max encapsulates all 3 of those columns. And if I run this query, and we got a little bit of highlighting to do here, don't we? This will return correct results, at least compared to the first query that we ran with the window function. And so like all the results here match what we would get from the window function version, but we get it much faster. What's cool here is that none of this query, even though we're in compat level 160, uses batch mode. The scan of the post table happens in row mode. You can see that just sort of over right next to my big head there. This compute scalar also happens in row mode. The hash match aggregate, which is totally eligible for batch mode, still goes in row mode. So basically, and of course, parallel exchanges like gather streams don't support row mode. So this whole thing finishes in about 2 seconds without using any batch mode whatsoever. So back before batch mode was really a cool, useful thing, this was a good method to get the max value per row. Like I said earlier, this can still be very useful if you're on standard edition, because if you're on standard edition, Microsoft doesn't think that you paid them enough to have your queries perform well, so you don't get, like, even if you got batch mode to happen here, you would be limited to a DOP of 2 for your batch mode queries. So you would not be like I have max DOP set to 8 for this. This thing will have used like a DOP of 8 for the query, right? You can see degree of parallelism right there, 8. So this thing would have used 8 cores up for this whole thing, and spreading the workload of 17 million rows out across 8 cores, nice and efficient, is pretty efficient for row mode and for batch mode. But like 17 million rows across 2 threads, even in batch mode, you're likely going to see some performance fall off there. Like whatever I don't know, maybe you'll get real lucky and the trade-off won't be too terrible, but the standard edition limitations there are really quite a pain. The next thing that that I want to show you is the window function version of this again, but without that compat level 140 restriction on it down here to prevent batch mode on rowstore from kicking in. So if we run this query, this will take about 2 seconds now, right? We get back the correct results. This finishes in 1.8 seconds, just like the carryover sort method that I showed you above. And we don't have to write that crazy max syntax where we convert like dates and numbers to strings and pad things and all that other stuff. Since this is Developer Edition, which is the Enterprise Edition equivalent SKU, I'm not using 2025 Standard Developer Edition, because why would I hurt myself that way? We are just using regular edition here, regular developer edition here. So this runs at a degree of parallelism of 8, and this runs nice and quickly and efficiently. So if you're writing window function, so like, you know, really the idea of this window function, right, is like we just want to get like the top row for each post type ID. So I'm filtering to where row number equals 1 for all these. If your goal is to find like the max value of something for a row based on whatever criteria, I just kind of picked 3 columns at random from the post table that seemed to like make sense. I guess I could have thrown score in there if we felt like it. But if you're doing that, like I still would have had to deal with potentially negative numbers because scores can be negative in the post table. So that like that maybe that wouldn't have saved me too much time or trouble with the carryover sort syntax. But if your goal is to like sort of find data like this and you're filtering to where row number equals 1, batch mode can make these queries crazy fast. Like you don't even have to add indexes, like just let batch mode on rowstore kick in, read from your table in batch mode, process all the data in batch mode. Like it's a way better way of running like big data crunchy queries like this. But if you're not in a situation where batch mode on rowstore can kick in for you, like if you're not on SQL Server 2019 plus and you're not on Enterprise Edition and your database is in compatibility level 150 or better, and there's no batch mode on rowstore, like naturally occurring, and like depending on if you can change stuff, like you can mess around with like column store indexes, you can mess around with putting just like having an empty table in your database with a clustered column store index, or creating a temp table with a clustered column store index, and like left joining to that thing. You can do all sorts of stuff to get like partial batch mode on rowstore, but it does not go as deep into your query plans as batch mode on rowstore, like the intelligent query processing optimizer feature does, which is kind of weird, I think, but it's just something that you learn to live with when you are tuning queries across a variety of strange environments. Anyway, this is just something that caught my interest and I felt like talking about. I hope you enjoyed yourselves. I hope you learned something. I hope maybe there was some good educational point in this video that you are able to take away from it, even if it's not memorizing the crazy syntax in here. I feel like perhaps there were a few good educational moments aside from that. But anyway, thank you for watching, and I will see you over in the next video. Adios.